Mr. Munyon here with Unit 1, Embedded Assessment 2. We're going to be going over the answers. So hopefully you've already attempted this section. I'll just be going through the answers, making sure you guys know the steps on these. You're welcome to skip through and check your answers if you feel confident. If you need some help, then make sure you watch the full video. So for here, we have an event. Charity hosts a fundraiser event. The walk starts in Reese Park and then continues along Bell Avenue. The route for the first section of the walk is along the east-west path. So they're starting in the east and going west. It starts at A, at the 32 marker on the path, and will continue to point B at the marker 4, shown on the diagram. So questions A, B, and C all pertain to this diagram. Let's make sure that we are able to answer these. The markers on the path are spaced 200 meters apart. What is the distance in meters from points A to B? So the only ones that are indicated with dots on here, or little markers, are every 4 markers. So from 4 to 32, we just find the difference. 32 minus 4 is 28. So there are 28 markers in between the 2 points. And if each marker is 200 meters apart, times 200 gives us 5,600 meters. So the total distance should be 5,600 meters for that first question between points A and B. Question B says a water station is located at the midpoint. To find the midpoint, you can just average these. So 32 plus 4 over 2 equals 36. Over 2 equals 18. And if we find where 18 is, 2 units away from 16 and 20, that does look like the midpoint, and 18 is 14 units away from both of those. So looks good. Question C. Do we answer the question for B? At what marker? Yeah, it would be at the 18. Marker 18 would be where the midpoint is. Question C says a first aid booth is located 3/4 of the distance from point A to B. What marker on the path is the first aid booth? So if the total distance is 28 markers away, we could figure out 3/4 of 28. 28 is very easily divisible by 4, so that'd be an easy way. Or you could do 3/4 of the 5,600 meters. It is asking what marker, so I'm going to go ahead and use the markers. So what is 3/4 of 28 markers? We can just do 3/4 of 28. And multiplying fractions ain't no problem. You can do top times top, bottom times bottom. But I also see that 28 is divisible by 4, so I get 7 times 3 equals 21. So 21 markers away from their starting point. So this is not our answer here. It doesn't mean that it's located at marker 21. That means instead of going 28 units from A to B, we only go 3/4 of the distance, 21 units. And also, a common mistake that students make is just going from left to right. You're not starting at B and going towards A, 21 more units, so 4 plus 21 at 25. This is not where it's at. It's 3/4 of the distance from A to B, so we need to go 21 units this way. So 32 minus 21 does give us 11. So the booth should be located at mile marker 11. So this was our midpoint, and this is our first aid station. So should be located at marker 11. All right. For the next section, question 2, we have a new diagram here that we can use. It says the second section of the walk continues from point B along Bell Avenue to a finish line at point C on the map. So they put point B and C. People are going to be walking here. Each unit on the map represents 1 kilometer. What is the distance in kilometers from point B to C? So we should be able to use either Pythagorean theorem or the distance formula. Whoops, don't know what happened there. All right. I see that if I draw the horizontal change, or the change in x and the change in y, I do get a right triangle. So you could use the distance formula, or Pythagorean theorem. The distance formula does just come from Pythagorean theorem. So distance equals however much the change in x is squared plus however much the change in y is squared. You may be looking at your formula chart and notice a formula that says x2 minus x1. That is the difference, or how much the x values change. And y2 minus y1 is how much they change. So I'm just using this little triangle symbol called delta for how much they change. So let's look and see how much does it change. Looking at my x values from 1 to 9, I could either find the difference of 8, or I could just ask myself what is the difference, or I could even do the Pythagorean theorem and count how far it changed. My change in x is 8. And my change in y from 4 to 10 is 6 units. Whoops. There we go, so 6 squared. So my distance then is going to be 8 squared is 64, 6 squared is 36, 64 plus 36 equals 100. So square root of 100 does equal 10. So my distance on that one would be 10 kilometers. All right. For part B, it says what is the total length of the race from point A to B and from point B to C. So on this one, we just need to add them together. On that first part of the question, we did get 5,600 meters, and it takes 1,000 meters to make a kilometer, so 5.6 kilometers plus 10 kilometers equals 15.6. So 15.6 total kilometers. For question C, it tells us that there is, I'm going to make some room down here. There is a water station located at the midpoint of BC, and there is another water station located at the midpoint of MC. So we need to find the midpoint. Couple of easy ways to do that. If you have a graph, you can just use half of the x value. So half of 8 units is 4, should be right here. For the y, half of 6 units went up 3. So I'm pretty sure that's the midpoint to get m. Or you can use the midpoint formula. So midpoint equals x1 plus x2 over 2. Basically average the x values and average the y values. Don't think of it as a formula. Think of it as, okay, I'll just average, find the middle point of it. So if I was to find the midpoint of BC, then I plug in the x coordinates for B and C. So 1 and 9. And the y coordinates for B and C, 4 and 10. So 10 over 2, 14 over 2, we get 5 and 7. So sure enough, 5 and 7, we do get m is at 5, 7. All right, so now that we know that m is at 5, 7, I can now find the midpoint of MC and find out where n is and see if it's at 6, 8. So if I go to 6, 8, it doesn't even look like that's on the line, which is a big indicator that's probably not the midpoint. Doesn't look like. So my initial guess is definitely that it's not the midpoint. So the midpoint of MC is going to be the same thing, but now I'm using M and C. So C was at 9, 10. So I'm going to use the x coordinates, 5 plus 9 over 2, 7 plus 10 over 2. So I get 14 over 2 is 7. 8.5. So n, definitely not 7, 8.5. And we do want to check just to make sure that that looks accurate at 7, 8.5. Does that look like the midpoint of MC? Yeah, so that means no, the coordinates of n are not at 6, 8. So no is our answer for C. We supported our answer by finding out where in would have been located for that other water station. We do still have a couple questions on the next page for part C. Excuse me, for question 3, parts A, B, and C. An artist is working on a design logo for t-shirts that participants in the walk will receive. He starts by drawing angle ADC so that it measures 60 degrees. Plus 35 does equal 60. And that question C now is, what was the postulate? We obviously did the angle addition postulate. All right, that concludes the embedded assessment over activities 4 and 5. Hopefully this, you got some confidence on here, or you cleared up some confusion. Good luck. See you guys on the next video.